A proportional relationship has a constant rate of change, and we can represent that rate of change using the equation y equals kx, y equals k times x, where k is the variable that we use for the constant of proportionality. All right, so as you can see here, k is the number right before x. And so in these first three equations here, we are to identify the constant of proportionality. And so that is the number in front of x. So number one, that'd be 5/4. And number two, that'd be 2.5. And in number three, that'd be what? What number is in front of x? Well, if we don't see a number, it's understood to be 1. There is an invisible 1 in front of the x. So the constant of proportionality there would be 1. Okay, so write those numbers on the blank there. When you're given a table and you're asked to identify if the relationship is proportional, you need to find k, you need to take your y values and divide them by the x values. So I would do that in every pair right here. I would take my y's and divide by my x's. So show me how you do that. Take your y value of 10 and divide by the corresponding x value of 2. 10 divided by 2, of course, is 5. Check the next pair. Y value of 20 over x value of 4. 20 over 4 is 5. Then you have 30 over 6. 30 divided by 6 is 5. And your last pair, y value of 40 over x value of 8. 40 over 8 is 5. And so as you can see, I got the same number each time. And because I got the same number each time, that tells me there is a constant rate of change. And so yes, the relationship is proportional. K, the constant of proportionality, is 5, we found. And to write the equation in the form y equals kx, I simply take what I found for k and put it into this equation. And so my equation would be y equals k, which is 5 in this case, x. Y equals 5x. And so what we're saying here is that our y values are 5 times our x values. Okay, I'll do the same thing in number 5 here to check to see if the relationship is proportional. I got to find, is there a constant rate of change? So take my y values and divide them by the x values. Do that for every pair. Okay, so for this pair, this pair, this pair, and this pair. And if there is a constant rate of change, if you take your y's and divide them by the x's and get the same number each time, then yes, it is proportional. And whatever number you get for when you take your y's and divide by your x's, that is your k, your constant rate of change. And so that's what you would plug into the equation y equals kx, just like we did here in number 4. Okay, number 5 here, if I check to see is there a constant rate of change, take y's and divide them by the x's. And this pair, if I take the y value of 11 and divide by the x value of 1, well, 11 divided by 1 is 11. So let's check the next pair, 16 over 2. Y value of 16 over x value of 2. 16 over 2 is not 11. It is 8. And so as you can see here, because I did not get the same number, there is not a k. There is not a constant rate of change. And so I would answer no. This relationship is not proportional. It's non-proportional. And if you answer no to part A, then we cannot answer parts B and C. So just cross those out. Okay, number 7 here, I have weight on top and cost on bottom here. Let me call the weight my x values and the cost my y values. That's normally how we do it. We call the top row our x values and our bottom row the y values, because our y values, the cost, depend on the weight. All right, so to find k, you take your y's and divide by your x's. You can use a calculator here, but just show me how you're putting y on top and x on bottom. So 225 over 3, I have $3 over 4 pounds, and then $3.75 over 5 pounds. Okay, so every time you divide your top by your bottom, you're going to get 0.75. Okay, every one of these will be 0.75, and so that tells you that there is a constant rate of change. And so yes, this is a proportional relationship. The constant of proportionality is 0.75. And so if we write this as an equation, it's going to be y equals k, and k is 0.75. Y equals k x. So y equals 0.75 x.